we will talk about binary tree and then we'll talk about recursive traversal. So what is a tree? In general sense, just a tree that has branches and leaves, but in data structure it has some other meaning. It is a specific nonlinear data structure that has a root node, and that root node has some children, and those children can be parents as well. So this is the overall picture of a tree, and we can see that this is the root, and these are the children, and these are also the parents of other nodes. Finally, we have the leaf nodes, and these are in the different levels. And the total from the root node to the leaf node, it's called height of the tree. So a tree is basically an abstract data type that represents a hierarchical tree structure with a set of connected nodes. In real-life application, it is used in hierarchical data structure also to store and search data, for example, in file system, in database, and also in network routing. So if we want to compare between list and tree, then we can see that for list, one element is immediately connected to the next one. And that happens for all the elements in a list. But for a tree, one element is immediately connected with two elements. So list is linear, but tree is not linear. So we can see here that there are some linear data structures, non-linear data structures. We have graph, we have queue, etc. So why should we use nonlinear data structure? To implement complex relationship between data. In some cases, for example, to implement file systems efficiently, for social networks, for routing, for organizational hierarchies, and for recommendation systems. In these cases, linear data structure doesn't work well, or it becomes really complex to implement it. In these cases, nonlinear data structure works the best. So for a tree, there are some terminologies that we are supposed to be using. These are root, that I have already told you. The first node of a tree is root. Then all the elements of a tree would be called node. Then we have child. Child is a node that has a parent. Parent is a node that has a child. Edge is basically the connection between two nodes. Leaf is the node that doesn't have any child. Subtree is any part of the tree. And height is the length of the longest path from the root to a leaf. Now binary tree. So this is a binary tree because for each parent we can see there are at max 2 children. But this is not a binary tree because we can see for the root it has 3 children. It is called n-ary tree. Now this is how we create a binary tree. We initiate a class tree node where the value will be stored in the value and it will have a left child and a right child. Initially they are initialized as none, and later on they are assigned values. So this is the root node. It has a left child, the value is 2. This is the right child, and here the value is 3. So this will be used later on. Now we do traversal. So what is traversal? For tree, graph, etc. other complex data structure, we do traverse to visit all the nodes, because here different algorithms are used to visit all the nodes. So there are 2 ways we can visit a tree. The first one is BFS, and which is breadth first search. The other one is depth first search. So for BFS we use queue. It is another data structure which follows the fast in fast out, which follows first in first out approach, and for DFS it uses last in first out approach. So for binary tree, Under DFS, there are three ways we can traverse, and they are pre-order, in-order, and post-order. This discussion will only learn DFS to solve a specific problem. To apply DFS for any node that I'm currently processing, I have to remember these three lines. Pop the node, mark the node as visited, push all the unvisited nodes connected to it. This is really important. The nodes have to be unvisited. So for pre-order, the root is visited first and processed first, then left and then right. For in-order, the left subtree is processed first, then the root, and then the right subtree. For post-order, the left subtree is processed first, then the right subtree, and then the root. So let's have a look at this tree. The first question would be, is this a binary tree? So far what we can see, yes, this is a binary tree because the maximum number of children any parent here is 2. So we can apply a DFS here. So we can do pre-order, we can do post-order, or we can do in-order. So this is the pre-order where root is visited and processed first. Here in-order, the left child and then the root or the parent and then the right. For post-order, the parent or the root is processed the last. Now we will implement this DFS using recursion. So first I will create the tree. For that I will need to define the class. So this is the class that will be used for the tree, and based on the picture I will create the tree here. The root has been initialized with tree node 5, then the children and the respective children until the leaf nodes are put here. Now we will implement the in-order traversal, and which is really easy. What we will do, we will define this name. So this is DFS, but I'm writing this in-order traversal, but I can rename this as in-order DFS. Then I will check if the node is none, I will return none. Otherwise, I will visit the left node first, then the root node, and then the right node. So that is how it's done, and I'm going to call this function in the main function and then see how it's done. The name has to be changed in a lot of places. So now run, and yes, this is the in-order traversal of the binary tree. So that was all with binary tree and implementing DFS with recursion for binary tree. This will be used in the problem that we will solve.